Hi, this is Alexi Karve. Today I'll be demonstrating some of the generative AI scripts and notebooks that I have learned while I took a class and some of the things that I tried. So I'm going to start with some simple things like the GANs, generative adversarial networks. So the first example that I'm going to show is the ability for the model to generate digits. Okay, so we are going to start with the standard MNIST data set, and the goal is, that we provide it with the samples of the digits from the MNIST data set so that it learns to create its own digits. Okay, we are not telling it which digit it is. Okay, that is not important. So we start by loading the data set, and once we start executing it, what it does is that it keeps comparing some kind of noise that we generate with the actual digits. Okay, so we start with some noise of this type, and then as it learns, what happens is that it starts with something like this. So in maybe the first few epochs, it will learn and it thinks these are digits, and slowly as it keeps learning, what it is doing is it's comparing with these digits, and every epoch we are going to keep providing it with another set of digits to learn from, one batch at a time. And you can see that slowly this is what it thought it's going to generate. Then we provided some more digits to it to learn, and we keep doing it. Okay, and I'm going to just keep browsing down below, so you see the slowly what kind of digits it's generating. You see right now this is what it generates. Let's go down, and over some number of epochs, slowly you see where it's going. Okay, so now you see these are the kind of digits it's generating. And then don't compare what you see on top with what you see on the bottom over here. This is just the next set of digits that are being provided in order to train it. What's important is like this top thing which is there over here, that should look like something that is generated, and it should be a digit. Okay, that is what is important. So if I go to the bottom now, after huge number of steps, you can see like there are some digits it's generating. Yeah, it kind of, this looks like 7, these look like ones, this look like 7, this is 8, this is 0, this is 3, and so on. So slowly it starts getting better and better at generating digits. So after a certain point, I basically stopped uh, running it further. But that was the idea of this basic GAN example. Then we have a similar example with the advanced GAN. This one was without any colors, so this was a simpler model. When we go to advanced GAN, what we have is some images of celebrities, and our goal is to use a similar kind of thing, but in this case we are going to use convolutions to train it. So we have these convolutions over here. So this is the neural network that will be used for the generation of the model. So we load the data set. So these are some of the celebrities in that data set, and we are going to use something similar that we did in the previous GAN. So if we start looking, you will see that initially this is what it generates. Okay, it starts from noise and it tries to generate based on some of the celebrities that we provide, and we keep doing that. Okay, and now what we're going to see is after about 35 steps, where are we? And then we continue providing more and more and more. Okay, so now this is still just the first epoch that we finished. Now you'll see that these are going to come nearer to each other, the generator and the critic losses which are there. And that's the idea, that they should come nearer to each other. They should come converge towards zero. So now you see, that some kind of features are actually being generated over here as we are in the first epoch, and we are now in the second epoch. So you see, what is being generated again as last time. Okay, these are not the same images that are being produced from bottom. These are generated images. The things that are at the bottom are just being shown, as these are being provided as inputs to the model, and the goal is to just generate an entirely new set of people. Okay, these are not real people. It is going to generate these people based on the input that is being provided. So we continue. I'm going to go to the bottom over here, and you can see what it is doing now. Okay, so after some number of uh, checkpoints, let me see how many checkpoints were there. Epoch were 52. After 52 epochs, 4165 steps, you can see these losses that are there. The critic loss is -6, generator loss is about 12. So it tried to overall converge towards each other. And if you see now, these are the kind of images that are being generated. Pretty good, right? I mean, if you look at these images, some of these images are very nice. And we'll pick one of the images over here, enlarge it a little bit. Then what we can do is we can convert from one image to another. So this is just showing that if you had one image, what it takes, to go step by step and move it to another image. So these are some of the things that you can do. So basically what it's doing is morphing by going into the latent space and then coming back out of it and coming to the new image. Okay, so this kind of morphing or interpolation between the images is what it is showing. Okay, so this was the second thing that I showed over here with the GANs. Although GANs do take a lot of steps, so stable diffusion is probably much better. There are other models like DALI and those, but that requires a huge amount of GPUs. Stable diffusion is something that we can do much easier on our standard GPUs. So what I will do is I'll show some of the examples with stable diffusion right now. Again, this is like the source from where I adapted this particular notebook is shown over here. Okay, and if you want to run this, first thing I'm going to do is I'm going to start from this Hugging Face model. I have to log into Hugging Face, get this particular download this particular model, and now that we have this, we are going to do some kind of inferencing, okay, where we, let's say, generate a prompt with swing in garden 4K detailed, and I'm going to run it for 50 steps. 7.5 is the guidance scale. That you can start with a smaller scale or higher scale, but 7.5 is much better. If you go too higher, then the image it generate is too sharp. If it is lower, then the images don't look too good. So guidance scale of 7.5 actually works quite well. There is generator, so we can change the seed. Every time we change the seed, new image will get generated. And right now the image height and width is shown over here. Let's see what the swing looks like. Okay, so this is what it showed, swing in garden. Yeah, we don't see the people too well, but it did generate some kind of swings over here. Let's generate some of the other model, just like if we do this prompt where I'm going to generate a digital illustration of a steampunk computer laboratory. And instead of 50 steps, maybe I will just take it to 30 steps, okay, because 50 steps just take too long. So if I take about 30 steps, let's see what it looks like. You do need to go about 50 so that it looks better, but 20 steps is not too bad. You can start to see those particular images. So here is this steampunk computer laboratory. Let's try one of the other ones, a futuristic city with townhouses covered by creepers. Let's try this one. Also, every time you start from a different type of noise, you will generate a different image. And I will change the noise so you can see what happens over here. So, well, something with creepers. Let's see what happens if I use some different noise, like maybe 24. And again, same number of steps will be used, but since it starts from a different noise, a different image will get generated over here. Okay. So you can see this now, it's completely different image from the one that was previously seen over here. There is one of the examples that I'm going to use later, which is going to be a pig wearing a white skirt. So maybe I'll show that one. Yeah, this is kind of funny. A pig riding a pig. That is not what I was expecting. But I have generated one image that looks quite well. That is just one pig wearing a white skirt. So every time we start with a different seed, it generates something different. Okay, so I don't remember what seed I had used for that particular pig image that I'm going to use, but that is okay. What I have done now is I have an image loop over here which generates an electric sky city on an alien world. So there are some number of inference steps like 50. If you run this, it actually generates all those images and puts them into a folder. I'm not going to run this right now, but it looks pretty good. Okay, and then whenever we get tired, we can basically stop that. So that was the keyboard interrupt. I'm not going to run that again, but I'm going to start this particular one. Okay, so I have one of the images over here, which are the shiitake mushrooms over here. And what I'm going to do with the shiitake mushrooms is I'm going to take some inference steps, like first I'm showing over here what kind of noise you can add to them. So you can start with a lot of noise and then slowly take those steps until they convert to the shiitake mushroom. So we are going to start with some amount of noise, okay, like 30. And then from the shiitake, I'm going to give it a prompt which says, okay, start with this image, okay, which has been added with some amount of noise, and then convert it to roses, something of that type. So this is what you see over here. This particular step is just going to show the same thing, but as a video after something like 200 steps. But what I'm going to be interested in is later generating a red rose, but for this particular shiitake mushrooms image. So our goal is to start from here, and then given this prompt of red rose, let's see, what it converts it to. But let's first see the video for this particular noise. There are a lot of advancements that have happened, since the class was conducted. So now a lot of things are done at the latent layer, so we don't do it at the image layer. Any changes that we want, we do it at the latent layer itself. And there are multiple papers on that. Anyway, let's look at this one. Okay, so you start with noise and slowly you can see, that it's getting converted to the shiitake mushrooms. Over 200 steps of noise, right? Now let's give it a prompt of red rose. I'm going to go up to 50 steps, but I'm going to start at step number 25. Okay, so 25 is something like, a little bit below this, between 30 and 20, so somewhere between these two, at half of them, and then I'll go up to step 50. So let's see what giving a prompt of red rose looks like if we start from the shiitake mushrooms. So you see how some of the mushrooms have been converted to red roses over here. So that is the kind of thing you can actually do. Now, all these things that I was running, okay, these were not really converted to functions. These were standard, just sections of code over here. Now, what I've done is converted it to functions. So all those functions for text embeddings, decoding the image latents, prompt to image, are there over here. And I'm just going to use prompt to image super cool anime character. Okay, and this is what it gets generated now. So every time you have a new one, a new image will get generated. Just try it again. Again, I'm only trying 20 steps, okay, but 50 steps, it becomes much cleaner and nicer. So you see a different image got generated over here. Let's look at the starry night with a violet sky, digital art. This is going to up to 40 steps. Most of us know what starry night looks like. So in this case, it is going to return all the latents. So we get the video frames. And once we have the video frames, Now what we'll do is we'll convert it to a video. Okay, the video has been created. And let's watch this video, the starry night. You start from noise and slowly convert it to the starry night, right? So you saw this video. Let's look at steampunk airship bursting through the clouds. Again, these are some of the standard prompts. You have to put something like cyberpunk art and so on. So it looks realistic. So in this case, now this is the image that was generated. And what I'm going to do is, in this case now, I'm going to start and only perturb the latents, okay, with 0.15. So we'll see, what happens. The image should look pretty similar to the one that we already had with some minor changes. So if you want the image to be very much similar to this one with some few changes, then we can do something like this. So now you can see, the changes that have happened. This didn't result in too many changes. Sometimes the results are drastically changed, like even with 0.15, let's change it to something like 0.25 and see what happens. Okay, so this particular image now got changed to this. You see at the bottom what happened. There is something new coming up over here, and the thing on top went away. Now there are some kind of things coming on top. Whereas the earlier image, there was something else on top over here, some kind of hot air balloon or something. So you can perturb the latents and you can see something different happening. But the main image does remain the same. You will still see the big thing that was in the center, that you still see it, the airship. Then there is a mixed guidance. So you can say that I want basically some kind of combination, image that should look like white pipes and maybe a python in a tree and maybe red flowers. So I put some percentage over here, saying that 50% of white pipes should be there in this image, and it should be something like some python in a tree, and it should also have red flowers. So let's see what it generates. If you give it some kind of mixed prompts. You see now that we have these red flowers, we have these white pipes like that look like branches, and of course there is a tree. I don't know where is the python. If you just had the python, then you do see a python. Then there is a denoising example, something like maybe Eskimos on a futuristic city on Mars. Again, this is just a video that is going to be generated, but it's going to show you, how it actually works. Okay, now just watch on the left side, watch on the right side. Maybe I need to reduce it a little bit so you see the full video. Okay. Right. So this side of it starts from noise, gets converted to the image. The next example that I'm going to show is with this pig, that we want to, let's say, just change the skirt of the pig to different, colors or something different. So I'm going to run this now. This was the pig image I generated in the previous section. I had created it and kept it available. So this is where we are using the clip and the clip seg repositories. So once you install the clip seg, then you can actually create a segment and then run it. So I have done that already. So I started with this pig image, and what I'm saying, I'm giving it prompts over here. I'm telling it that I want it to figure out where is the face, where are the legs, where is the skirt, where is the white dress and the grass. So it comes back with the head, the legs, the skirt, the white dress, and the grass on the side, which is yellow in color that you see over here. This is the mask that it created. Now what I'm going to do is I'm going to tell it to convert the skirt to different kind of prompts that I'm going to give. So this is the mask that I've given. So this time I gave, like some prompts saying skirt with bees, skirt with protruding blue flowers. So you see those protruding blue flowers over here that it generated. So what I did is I said that I want these prompts, but only within that area, which is the mask area called the skirt. Okay, and that is what it's doing. So the same pig now, it has these skirt with bees, blue flowers, then embroidered white flowers over here, then a zebra skirt, and then finally a rainbow. I gave a skirt with rainbow, so that's what it looks like. And if you look at the masks, like the face mask, if you put on top of it, this is what it looked like. Legs, this is what it looks like. The white dress, so it's showing those masks on top of the actual image now in this example. I'm going to show one more example over here. So in this case, I did not have the prompts. So this is the same image again. Okay, and once I ask it to show the annotations, now it's showing you all the regions over here that it found. So all these are the annotations. So now we have to select one of the annotations. So this is not recognizing it as a skirt. I have to tell it specifically, this is the one that you need to modify. Okay, so in this case, the segments were just generated. These were the areas that it gave. And now we have to say, okay, I want to use this mask called number 7. So 7 is the skirt, 12 is the skirt and blouse, and so on. So this is what it detected now. And now when we give skirt with red stars or skirt with blue circles, stripes, zebra skirt or skirt with balloons, then we can actually generate those images. So here it shows, skirt with red stars, then blue circles, and with stripes, zebra skirt, and skirt with balloons. Right. So in this, I just wanted to quickly show, that what is possible with generative AI. There are a lot of other examples that I have. I'm still playing with them, and I will continue to work on some of these examples. But this was just, some kind of fun thing I wanted to show about what is possible with generative AI, and we'll have fun. Thanks for watching.